right here. What we get is 3 raised to the power 4 plus x. What we get is 4 into 3, which is 12x, raised to the power of 3 because, well, 4 minus 1 is 3. And as we previously saw, x raised to the power of 1 minus 1 becomes 0, so that's 1 into 1 leaves us with 1. Now we have to apply the chain rule on these equations, or these expressions rather. So in order to get the differentiated expression, to get dy by dx of this entire equation, what we do is dy by du, which we found right here, into du by dx, which we found right here. So what we end up with is du raised to the power of 4, because that is the value for dy upon du, and we multiply that by 12x cubed plus 1, which is what we found here, right? Now we have to substitute u back into the equation. So earlier we said that u is equal to 3x raised to the power 4 plus x. Substitute that back into the equation. What you get is 5 into 3x raised to the power 4 plus x raised to the power 4 into 12x cubed plus 1. That is basically the chain rule. Now, using this new methodology of chain rules that we learned, we can apply this in the product rule. So basically, we can say that u is equal to x squared because, well, let's consider u to be equal to x squared, and v is equal to 3x raised to the power minus 1, 3x minus 1 raised to the power half. We know that anything that is being square rooted can be written as half, or raised to the power of half. So when we differentiate u with respect to x, what we get is 2x, because you're multiplying, well, 2 with 1, which gives us 2x. 2 minus 1 is 1. Now let's try to understand what's actually happening here. You have 3x minus 1 raised to the power of half. We can't directly put half here. What we have to do first is find the differentiated value of this 3x minus 1. So what I like to do is this. One second, let me show you. Is say that some variable, let's just say z, is equal to 3x minus 1. So this is us using the chain rule again. So when we differentiate this, we get 3, right? Because 1 into 3 is 3, 1 minus 1 is 0. This doesn't have any x value, so it's already 0. So what we're left with is 3. You take the 3 outside and you multiply it by half. Well, because you get z raised to the power of half here. We know that z is equal to 3, and, well, when you sort of differentiate this, you get half z. So that's half into 3 raised to the power of, and you have to subtract this as well. You have to subtract 1 from this. So what you get is 3x minus 1 raised to the power of negative half. So that's the that's differentiation of v with respect to x. And then in order to find our final dy by dx, what you do is multiply u with dv by dx plus v into du by dx. So we know the value of v. We know that v is equal to this, right? And we know that u is equal to this. So when we simplify that and plug everything back into the equation, what we get is this. That's our final differentiated equation, dy by dx. All right, that's all for multivariate calculus. Let's go on over to probability. So probability is basically the likelihood of a particular event to occur, and it is the equation, or the very basic probability is given by the desired outcome upon the total outcomes. An example of this could be flipping a coin. What you would get is either heads or tails, right? So, well, the desired outcome is tails, assuming that that's what we want. and the total amount of outcomes that are possible are heads and tails. So there's two possible outcomes, right? Or there's actually one possible outcome. So that becomes our desired outcome, and there's two outcomes that can happen, right? You can either get heads or tails. Therefore, the probability of getting heads or tails, considering the coin is not biased, is 1 upon 2. And we should always keep into consideration that when you add up the sum of all outcomes, that is equal to 1. It's always equal to 1. So let's go on over to some basic terminologies of probability. So you have random experiment. A random experiment is basically an event for which the outcome we cannot determine with certainty. Again, flipping a coin, we can't always tell whether it's heads or tails perfectly. Sample space is the possibilities of all outcomes of a random experiment. So the possibilities of all outcomes of a random experiment. What that basically means is there's two possible outcomes of a random experiment. In this case, there's two possible outcomes of flipping a coin. You can get either heads or tails. An event is one or more outcomes of an event. It's the sum of one or more outcomes of an event. I probably forgot to add some there, but let's go over to types of events. So you have two types of events, joint events and disjoint events. Let's start off with joint events first. Well, joint events are basically outcomes of a particular event that have something in common. If you were to put this in a set, what you would get is, let's say that there's an outcome A and there's an outcome B. There would be some sort of common sort of outcome that can occur while you're conducting this event. Disjoint events or mutually exclusive events are events that don't have common outputs. Therefore there's no joining here of these two sets, right? Let's go on over to types of probability. There's marginal probability, there's joint probability, and there's conditional probability. Let's start with marginal probability first. So it is basically the probability of occurrence of a single event. For example, if we want ace, just ace, any ace card from this deck of cards which has 52 cards in it, the probability of that would be 4 upon 52, right? Because you have 4 cards, and if you were to pick any ace from this, it would be, well, you could pick 4 aces out of 52 cards, so the probability is 4 upon 52. Next, let's look at the same example for joint probability, and it is basically the measure of two events that happen simultaneously. For example, if we want the ace of spades from this 52 deck of cards, from these cards, then, well, the probability of that happening is 1 upon 52, because there's only one ace of spades in the 52 deck of, well, in the deck of cards, right? In the same way, let's say you have the king of diamonds. The probability of getting king of diamonds is 1 upon 52 again. Now, a point that I forgot to mention when I was talking about joint events is an example. So, for example, I'm writing an exam on linear algebra and multivariate calculus. I can score 100 on both of these exams, right? That's possible. But I don't know if any of you are into cricket, but let's say that you're getting a batsman out on their balls, and, well, we know that the batsman can't hit a 6 and get out on the same ball, right? That's technically impossible. Therefore, that event won't have anything in common. Okay, let's go on over to conditional probability. So, conditional probability is the likelihood of a particular event occurring based on the occurrence of the previous event or the outcome of the previous event. So, well, conditional probability of an event is the probability that event A has already occurred. What this basically means, if A and B are dependent on each other, then the expression for conditional probability is given by the probability of A and B occurring upon the probability of A. Well, this notation is known as the probability of B occurring if A has already occurred, right? And if A and B are independent events, then we would see that the event of the probability of B occurring is, well, the probability of B occurring, right? Because it isn't dependent on the probability of A. So let's look at an example of conditional probability. So let's say that Susan took 2 tests, and the probability of her passing both the tests is 0.6, and the probability of her passing the first test is 0.8. What is the probability of her passing the second test, given that she's passed the first test? So we have to find the probability of her passing the second test, considering that first test has already been passed. So as we saw that the probability of A and B are taken into consideration. In this case is 0.6 upon the probability of the first test being passed that's already occurred. So that's 0.6 upon 0.8. What we get is 0.75 or 3 upon 4. All right. So that was all for probability. Let's jump right into statistics and let's look at a few basic terminologies. Population, a collection or set of individual or objects or events whose properties are to be analyzed. So let's look at this example right here that we've got going on for ourselves. So let's say that this is my fish tank, and this has, well, a goldfish, a shark, why not, some pink colored fish, and let's just say this weird yellow colored fish. So this is my entire population of fishes. Let's look at what a sample is. Samples are basically subsets of a population, right? So as we can see here in this example, this is an example of a good sample size, right? Of a good sample, because, well, let's see these 2 golden fishes. There's 5 of them here. There's 2 of them in our sample. There's 4 of these pink fishes here. There's 2 of them in our sample. There's 4 of these sharks here. There's 1 of them in our sample, and there's 5 of these yellow fishes here. So we've basically taken into consideration all the species of these fishes, right? That's why this makes it a good sample. And this would be really essential when you're trying to pick up data sets online in order to train your model, which you'll see in next week's course or whenever the next workshop is happening. So I believe that is it for this workshop. From my side, thank you all for coming, and I will see you all next week in the machine learning workshop. Do you guys have any questions for me?